Hello, welcome back. This is Calculus by Dr. Oz. Today we're going to go over an exercise where we're going to find the standard equation of a parabola by given some information about a parabola. In part A, we're given the vertex and focus and just that. By using this information, how do you get back to the standard equation of a parabola? And in the second case, we're given the latus rectum, the endpoints of the latus rectum together with the directrix. So these are two specific information, and I'll explain what latus rectum means in the video. And by using these two, we're gonna sort of find or come up with the standard equations of parabolas. And at this moment, it's better to remember or recall a standard equation of parabolas depending on the axis of parabola. You have vertical axis and horizontal axis type parabolas. In one case, x is raised to the x term is raised to the power of 2, and in the other case, horizontal case, y is raised to the power of 2. And to be able to write down these equations, all you need is the coordinates of vertex, which is h and k, as well as p. And p is the distance from the center to focus, as well as the distance from the center to directrix. Okay, so by knowing those, we are going to try to come up with the standard equations of parabola for each case. Okay, so let's get started because we have two examples to go through. And all right. All right, let's look at part A. We're given the vertex to be -3 and -1, and the focus to be -3 and 1. We are going to try to come up with the standard form of the equation of the parabola. So as you see that the x coordinates here are exactly the same from the vertex to focus. And let's see what kind of parabola satisfies this. The only increment from vertex to focus is from 1 to -1. So you're talking about 2 units apart from each other, right? A vertex and focus. So, but that's also in y coordinate, okay? So let's go back to the standard equations of parabolas. You have two kinds, obviously. One comes with vertical major axis, and the other one is horizontal major axis. Okay, so let's see. Here, the vertex is coming with the coordinate h and k. Okay, for sure. So h and k, and I said that h is the same for the focus, but there is an increment p. So we were talking about this type of parabola. So we should have x minus h quantity squared, 4p y minus k type formulation here. So let me just write that down. X minus h squared, 4p y minus k. And in fact, we know exactly what h and k are, because that's the location of vertex, right? -3 and -1. And as I said, focus is h k plus p. So it's already -3 and 1, but k is -1, so k plus p equals 1, for k being -1 means that p is equal to 2. Okay, so I can go ahead and then just plug everything back in because I know h, I know k, I know p, right? So x minus h quantity squared equals 4 times 2 times y minus k, y minus -1. Okay. All right, I can go ahead and simplify this. So essentially, this is x plus 3 squared, 8 times y plus 1. You can leave it as is, or you can just like expand it all the way, but I think it's a good place to stop here. And also, I want you to visualize this. Once you have the equation of the parabola, why don't you go ahead and graph it and make sure like you have the right vertex and focus given in the statement of the question. You can have your TI-84 right now. Pause the video, please, and try to graph this parabola here. Okay. And I have done that for you. So you have the focus to be at -3 and 1. and you have the vertex to be located at -3 and 1. So as you see that this distance here from here to here is 2 units, okay? Because p equals 2, and you could also find the directrix by having the distance from here to here 2 units, okay? So essentially this could be your directrix, okay? Y equals -3, okay? And that's it. So this here, the major axis is vertical because that's the axis that connects the focus and vertex, okay? So essentially, think that about as a mirror, okay? That splits the parabola into 2 parts, okay? All right, I think that takes care of part A. We can now consider part B, but that's going to be in the next video. Please move on to that, and I'll see you over there. Bye.